presentation on the course Signals and System. Okay, now Signals and System, which is applicable for third year as well as for the second year as per the syllabus and the new structure. This is the broader objectives of the course. First objective, to apply skill to solve problems which are related to the signals as well as system classification, signal classification and its properties. Second objective is to know the Fourier series and Fourier transform for representation of periodic and non-periodic signal. That is the second objective in that sampling theorem, Fourier series, Fourier transform. This part we are going to cover. Third objective, to analyze the system in time domain as well as in the frequency domain by applying Z transform, and we also solve the problem on the inverse Z transform. And the last objective is to analyze the signals using discrete Fourier transform. So there is a how to find out the discrete Fourier transform, what is the meaning of overlap add method, overlap save method. Up to this we are going to consider all the points of the discrete Fourier transform. Then the next, what are the objectives of the unit 1 that we are going to consider in the signals and system course? The first objective is the classification of a signals. Then the second one, plotting of a continuous time as well as a discrete time signal. Then transformation of independent variables. So there are different transformations for plotting of a different, with the transformation plotting of a signal is carried out. Then calculation of even and odd part of a signal. That is the last objective related to the only for the signals. Now the general introduction, what are they, what is the signal and what is the system. So overlook about this we are going to see. So signal is a function of one or more variables, means any signal we can say here, and variables are different, any function variables that convey information on the nature of physical phenomena. So any information that we are going to plot by using a signal. For example, there are different signals are mentioned here, V of t, I of t, x of t. These are the nomenclature we are changing, but it is a vary with respect to time period t. Next one, we are going to use the heartbeat, that is the ECG, cardiogram of the human body, that also we are going to observe. That is a one type of signal, measuring of the blood pressure, then temperature, then vibration. These are some examples we are going to consider, which gives the information related to which gives the information, and it is a vary with respect to time period, it is vary with respect to frequency, any type means which type of signal we are going to use over there. The next one is the one dimensional signal. So in the one dimensional signal, the function which depends on single variable, for example speech signal, this is one example, it depends on only a single variable, that is a speech signal. Same thing, one dimensional signal, we can say that the cardiogram also, it is a one dimensional signal. Then second part is the multi-dimensional signal. So functions which depends on two or more variables. So these are the multi-dimensional signal. For example, we can say that two-dimensional image, three-dimensional image, multi-dimensional image. Means according to the information, if you want to find out the depth of the signals, you need three-dimensional signal. If you want to find out the image in terms of pixels, so we required the two-dimensional signal minimum, at least two-dimensional signal. We can also observe the three-dimensional signal also, which gives the information about the image. So these are the different types of signals. Generally, it is a general explanation about the signal. Now, what is the fundamentals of signals and system? So we study about the signals, but now we are going to focus about the system. So system as an entity or operator that manipulates one or more signal to accomplish a function, thereby yielding new signal. So means we are going to operate on the input signal as per our requirement, that is called as a system. Okay, then the next one is the common encountered system, that is a communication system, automatic system, speaker recognition system, then aircraft landing system. It is a one type of system, but input is given in terms of any signal, and we are going to process on that and find and making the system which is give the proper output. That is the major aspect about the system. Now, classification of a signal, which is important point of our course objective. So continuous time and the discrete time. When you observe this waveform, we found that there is a first diagram is a continuous time system, or the continuous time signal, sorry, and the second one is the discrete time signal. So, in the continuous time signal, on the y-axis x of t is mentioned, on x-axis the t is mentioned, that is a small t. The signal which vary with respect to time period t, it is called as a continuous time signal, and the signal which is vary with samples, that is a n, here in the second diagram, signal on the amplitude axis x of n is present, and the time axis or the x axis n is the samples. So, we are going to observe the samples here in this diagram, and here we are going to x of t, we are going to observe about the continuous time signal vary with respect to time period t. Okay. Now, classification of signal, again there are, it is a continue part of the previous one, continuous time, discrete time. Now we are going to represent the continuous time and discrete time. So for many cases x of n is obtained by sampling x of t, right? Means generally what happened in the previous diagram, when you observe this diagram, we found that it is just a approximate. When you approximate the discrete time signal, that is x of n, you will get the x of t signal. It means that we are going to sample x of t and convert into discrete format. So because of that, it is mentioned here, it is obtained by sampling x of t. So as x of n, x of nt, it means that n varies from 0, plus minus 1, plus minus 2, plus minus infinity. So means plus at equidistance between the two samples. It is not like that 0th location, then second location, then 4th location, but it is the duration between the two samples should be unique from minus infinity to plus infinity. Therefore, it is generally we are going to say that it is related to the sampling. Then next part is the even and odd signal. This is the brief introduction about how to find out. Previous one, we in point number 1 we studied about what is the x of t, what is the x of n, how we can represent the signal, how we can plot the signal. Now how to find out the even and odd signal. See, in the even and odd signal, x of minus t means which is equal to x of t. So actually transformation of independent variable, we are going to study about x of minus t and x of t. It means that it is taking a mirror image of a signal. When you are going to take the mirror image of signal x of t and which is equal to x of minus t, this is called as the even part of a signal. X of minus n which is equal to x of n. This is in time period, this is in discrete, this is in continuous time format, this is in discrete time format. Then x of minus t which is equal to minus xt, x of minus n which is equal to minus x of n. So that is called as a odd part of a signal, means odd signal. This is the even signal, this is the odd signal. We can complete first the classification, then we focus about the transformation of independent variables. Okay. So here it is mentioned, another example is that xt can be expressed as, how we can express the xt likewise, x0 xet plus x of t means what, even part of a signal plus odd part of a signal, it is called as xt. We can also present x of minus t which is equal to even part of x of t minus odd part of x of t. So that is called as subtraction. It is represented as a x of minus t, and x of t is represented at the addition. This we can also present in the by taking the support of above two signals. Now the next one is the xet, that is how to calculate the even part of a signal. So by using this formula, 1/2 xt plus x of minus t, and the odd part of a signal 1/2 xt minus x of minus t. The remaining part at the time of even or odd calculation, that we can see the details about that. So these are two formulas to find out even and odd part of a signal. Now another type of signals are periodic and the non-periodic. Periodic means what? The continuous time signal if x of t equal to x of t plus t. That is, it is a xt is a periodic. So smallest t, that is called as a fundamental period. Fundamental frequency, t means what? It is a fundamental period. I already explained that the periodic signal means when you are finding out, suppose for example continuous sine wave from minus infinity to plus infinity, if you are going to consider the time period t, full cycle, starting of a cycle to end of cycle, it will remain constant from minus infinity to plus infinity. So xt we can represent x of t plus t, means any period we can any signal we can pick up, because it is a periodic signal and it will give us the information about that signal. So the t is the time period that we are going to decide the fundamental frequency. From that time period of the signal we can calculate f is equal to 1 upon t by using this formula, and also we can find out the angular frequency 2 pi omega. So this is the radians per second. If you want to hear, the term is missing, 2 pi omega is there. So if you want to find out in the radians per second. The next part is the discrete time signal. If x of n is same way, just like a continuous time signal, in dt signal also x n plus n, capital N is the duration between the two samples and capital T is the duration between again two sample for the continuous time signal, means two cycles, that is a single cycle. Then likewise here the duration between the continuous duration, here the discrete time signal. So x of n is a periodic when x of n equal to x of n plus n. So what is this n? It is a fundamental period, and again same way it is a f is equal to 1 upon n naught, that is a cycles per samples, we can say here cycles per second. In the continuous time signal it is a cycles per second, discrete time signal it is a cycles per sample. Here we are going to find out angular frequency, and here the angular frequency instead of 2 pi upon t naught, here it is a mentioned 2 pi upon n. That is a, if you are going to consider the samples, that is a radians per sample. Okay. Then a sampled continuous time periodic signal may not be discrete time periodic. Any condition adding up two periodic continuous time signal, resultant must be periodic signal. So it is a one note they have mentioned, that you can take the care about this one. Now the another type of the signal is the deterministic, signal is the random signal. Deterministic signal means what? There is a no uncertainty with respect to the value at time, completely specified at any time. And the random signal means what? Uncertainty before it occurs, that is thermal noise. That is called as a random signal. Deterministic signal means there is a no uncertainty with respect to the values at any time. That is a completely specification at any time, specified at any time. And the random signal means it is uncertain before it occurs. For example, thermal noise, it is a one example is mentioned. Now, how to calculate? Another type of the classification is the energy and the power signal. So, continuous time signal x of t, energy is calculated. How to estimate, calculate the energy or the power signal? So, energy is calculated integration minus infinity to plus infinity x square t, squaring of a signal, that is called as a energy calculation. Power of the signal is calculated by using this formula, squaring for minus t to plus t for the defined time period, and limit is mentioned here, t tends to infinity 1 upon 2t. By using this formula we are going to estimate the power, energy and power signal, it is mentioned likewise. Okay. Now the next is, same way we are going to use for the discrete time signal. Instead of integration minus infinity to plus infinity, here we are using a formula summation minus infinity to plus infinity, n varies from, and the limit is also same here also. Instead of t to minus t to plus t, we are using minus n, capital N to capital small n, sorry, capital N, again minus n to plus n. Then analog signal and the digital signal, how we can represent? There is a, in first diagram, first leftmost diagrams are analog signal. In that it is mentioned that example of a continuous time and discrete time signal. About two diagrams, continuous time signal and the discrete time signal. Okay. Then below it is a example of continuous, another type of the example is mentioned here, the digital signal and the analog signal. Okay. That is the discrete value signal and the continuous time discrete value signal. So these are the means type of a signal that we are going to study in the classification of a signal. These are the basic operations we are going to operate on the signal. The amplitude scaling. Amplitude scaling means what? Just a multiplication of any constant value, that is called as amplitude scaling. Means x of t is there, we are apply c, y of t equal to, just observe the CT block, y of t equal to c into x of t. It means that we are multiplying some constant value c. When you observe the dt block, Here in that t instead of t, it is a cn and yn, xn and yn, and multiplied by c here. C should be greater than 1 or C should be less than 1. So greater than 1, it is, that is a one notification, it is a mentioned, it is not a part of this operation on the signal. Okay. Then the addition means two independent signals are there, x1t and x2t. So complete signal we are going to add y of t equal to x1t plus x2t. In the similarly, instead of discrete time signal, here y of n, x1n, x2n. Multiplication y of t, x1t and plus x2t, and discrete time signal y1, y of n is equal to x1n plus x2n. That is, multiplication is the x1n into x2n. Differentiation again d by dt x of t, which is equal to yt, and there is a no discrete time case is available for the discrete differentiation and the integration. Integration, whatever we studied, in the same way here, minus infinity to plus infinity, x of t, tau and d of tau. Time scaling means what? It is inside the bracket because it is related to the time axis. So it is not externally multiplied to the whole signal. It is very important, and because of that, this is the one type of transformation we are going to use for the problem solving. So y of t equal to x of at. So a is the multiplication parameter to time axis. So depends on that, a is a greater than 1, a is a less than 1. So if it is greater than 1, it is a compression, less than 1, it is expansion. It means that, for example, y of t equal to x into 2t. It means that compress the signal by 2, means the time axis divided by 2. And if you are going to use 1 half t, a is equal to 1 half t, which is less than 1. If you expand, that is, the signal is expanded by 2, means t, if it is the signal x of t at 1 present, it will multiplied by 2, it is shifted to the second position. So likewise, the expansion, the time scaling occur for the continuous time signal. In the same way for the discrete time signal. Okay. Then the reflection I already explained, that is a time reversal. That is a time reversal means what? Taking a mirror image of a signal. That is a time reversal, y of t equal to x of minus t, y of n equal to x of minus n. We'll see the problem solving again. Means what? Mirror image means what? There is a no change in the origin. Left side will be transferred to right, right side will be transferred to left. That is called as a time reversal or the mirror image of a signal. Then time shifting. In the time shifting, we are using y of t equal to x of t minus t naught. That is the time shifting by t naught. So t naught, what is the meaning of that? If t naught is greater than 0, then it is shifted to right. If t naught is less than 0, it is shifted to left. It means that, suppose for example, x of t minus 2 is there. T minus 2 means signal x of t shifted by 2 unit towards right, because t naught is the greater than 2, right? If it is a left side, means t minus up, if it is a shifted to t plus 3, it means that signal shifted towards the left side by 3 unit. In same way, for the discrete time signal also, x of n minus n naught, right side and the left side. Then combination or combination, that we can see that x of t equal to the combination of all x of a into t minus t naught, x of k n minus n naught. That type of the combination also we are using for the problem solving. Then basic operation of a signal, means how we can operate on the signal. Okay. In that, rules for time shifting and time scaling. What are the rules? When you observe this, the basic operation of a signal. So in that, in the first x of t, observe the first diagram. It is a -1 to +1. It shows the amplitude 1, that is x of t. Then find out x of t plus 3. It means that time shifting towards the t plus 3 means what? It is an advanced signal shifted left side by 3 unit. ठीक है, t plus 3 if it is there, then it is a x of t shifted by 3 unit towards the where left side, right. Then the next operation is x of what is this, y of t equal to y of time scaling is there, right. Time scaling means what, expansion and the compression. So if you are going to y of t, that is y of 2t, means whatever the yt we find out here after the shifting, and if you want to shift over there, so y of 2t means compress the signal by 2, okay. Then just observe the next signal, that is the last signal, x of t. Okay, operation of the scaling is there, x of 2t means 1 will be shifted to 1/2 position. Observe the time scale. Only for the scaling we have to observe the time axis, and in the time axis this is 1 and we want to scale by 2, that is a x of 2t, that is 2 is greater than 1, it means that it is a compressed by 2, compression is there. So 1 divided by 2 means this 1 divided by 2, and minus 1, the another signal, it will start from minus 1 to plus 1, minus 1 divided by 2 means it is again shifted to minus 0.5. So minus 0.5 to plus 0.5 you will get the signal, that is the compression. Amplitude does not change, amplitude remains as it is. When you observe the after this compression, if you want to shift the signal, so that we can say that suppose v of t we are calling this signal after the scaling, so yt is equal to v of t plus 3. It means what, compressed signal will be shifted towards the left side by 3 unit. Okay, so elementary signals are mentioned here, some exponent, that is the exponential signal, exponential decaying, exponential growing. If it is 0, okay, there is a DC components values are there, that is called as a exponent signal, means e to the power at. It is mentioned that e to the power at, if a is a less than 0, it is a decaying signal. If a is greater than 0, it is a growing signal. So less than 0 means e to the power minus at, greater than 0 means it is a positive signal, e to the power 2t, likewise. Okay, so in this way it is applicable for the discrete time signal also. So continuous time as well as the discrete time signal, the operation by or some signal, elementary signals, we are going to say that exponential and the sinusoidal waveform. In the sinusoidal waveform, we can plot the signal x of t equal to a cos of omega t, cosine wave, sine wave, sinusoidal waveform, and the angle is phi. So it is a minus infinity to plus infinity, and it is a scaled by a. A is the constant value or the amplitude value over there. Now, step function, that is a unit step function. Unit step function means signal which shows amplitude 1 greater amplitude 1 for t greater than equal to 0, means from 0 to plus infinity the signal shows amplitude 1. In the same way, for the discrete time signal, unit step signal greater than equal to n greater than equal to 0, that is a u of n, it shows the amplitude 1. In all other cases it is a 0. Now, unit impulse response. Impulse means what? The signal which shows amplitude 1 at the 0th position, that is called as impulse response, and that is represented by delta t. Delta t equal to, delta t is there. So, t is not equal to 0 at the 0th location. Only at 0th location it shows amplitude 1. In the same way, for the discrete time signal, delta n is equal to 1 for n equal to 0, and 0 is in all other cases. Right. Then unit ramp signal. Unit ramp means what? Increased signal, that is a ramp. T greater than equal to 0. It shows amplitude t. Right. That is unit ramp signal. Similarly, in another way, we can say that t into ut, because u of t means what? It shows 1. U of t is equal to 1. If you are going to multiply, there is another type of the signal, t into 1 is equal to t. So it is again a one type of the unit ramp signal. So that is mentioned here, the unit step and unit ramp, right. Then H represent the system. Here example, xt is a input, it is a system, and output is a y of t. This is for CT signal and this is for the DT signal, and these are the different types of the, it is just a structure of the system. So thank you very much for the today's lecture. We study about different parts of the how we can study up. We have classification of a signals, continuous time signal, discrete time signal, again operation of a signal, then different types of a signal that we studied. The remaining part of the plotting of a signal with the transformation of independent variables that we see in the next lecture. Thank you very much.